just before it does a slight delay. We've had all sorts of tech problems this morning, but finally we're online with you guys now and looking forward to sharing what I think I'm really honored and delighted to introduce you to Tejas Sindal, the founder of Carboncraft Design, joining us all the way from Mumbai. Is that right?
Yeah.
All right, welcome Tejas. Thank you for joining us to discuss a really important topic, which is climate change, and specifically development goals, and also to just share what you've been doing and how that really contributes to the overall global shift that we need to make when it comes to climate. So thank you for joining us. Do you want to
Hi, Nimisha. Thank you for having me. It's been an honor, I would say, to be a part of this and be able to share what we're doing. There are some great speakers and panelists around with whom I would love to sort of share the stage and share what we're doing and how we can combat climate change together. Shall I go with a full screen?
If you can, that would be great. You should be able to do so. Fantastic. Perfect. There you are. So over to you.
Yes. So what we do is I'm the founder of Carboncraft Design, as Nimisha rightly mentioned. We build products by upcycling air pollution. So I would like to sort of start with the argument that we really have around this entire issue. So what essentially we might do with this entire presentation is we might do a 20-minute sort of a presentation and then move into a more interactive sort of a session.
Absolutely.
So with that, we all know air pollution is a global phenomenon. But have we accepted this, or are we ignorant about this entire thing? So starting with this image where the kids are playing, have we accepted that it's going to be around us? Just a simple thought around that? Or are we ignorant that it's okay, it's just going to be there? So what is it? What is this entire thing about air pollution and how we're dealing with this? But what is air pollution? At the end of the day, we all speak about PM 2.5, PM 10. What are these essentially? So PM is particulate matter, and 2.5 and 10 is the size. It's a micron size, essentially, right? So anything that we can't see from our naked eye is PM 2.5 and lower than that in terms of size. And it could be foul air, it could be organic, inorganic pathogens, heavy metals out in the air, basically, which is all we are breathing right now. It is there in your lungs and my lungs at the same time, because it's not very different in your city and my city. It's just more worse in my city at the moment, that's all. To get a sense around what this really means in terms of size, imagine this is the grain of sand, basically. That is what would be the size of PM10, and that's what would be the PM 2.5. So this is the size of grain. So if you have the size of grain as really small, you won't even really see PM 2.5 particles. And a fact around this to relate it with the situation that we are around, which is COVID. COVID, the virus, is 25 times smaller than the PM 2.5 particles. It's 25 times smaller. So now you know how small it is and how easy it is for these particles and for the virus to really enter into your body and create all the problems that it's really creating around us. So how does this really happen? So there are various reasons. There's crop burning, there's forest burning, entire forest that we saw in Australia and in the Amazon burning. There are these stacks of chimneys which are giving out all the pollution. There is, say, construction going on, transport. There are various issues that really contribute to this entire problem of air pollution. So facts around this, we all know that there's somewhere about 9 million deaths that happen in a year. That's only due to air pollution, 9 million. So again, if I have to relate this back with COVID, how many deaths have we really seen worldwide right now? That would be somewhere about 200,000 or 250,000. But that's creating that kind of a panic. And it's why I'm saying this is we need to realize that this air pollution is also that big an issue. We have 9 million deaths, and we're not really tackling it with that sort of a pressure and issue as we are dealing with COVID right now, because it's just not seen. That's all. It's an invisible problem around us. And we are seeing that right now. And I'm hoping that this entire situation is going to only help us all to realize the issue around air pollution as well. But does that mean that we should stop development? Because what is the impact of development versus the air pollution that we have? So does that really mean we should not develop at all and stop consuming, stop living in cities? And what do we really do for that? And having understood that, what is the impact on construction? And understanding the scale at which we are sort of building at the moment. So this is one of the stats which say that we build an entire New York City every month for the next 40 years. And we are going to be just say double of what we are on Earth in terms of our capacity and infrastructure. And that is the scale at which we are building right now. And imagine the scale, the entire city of New York built in a month. And over and over and over and over again for the next 40 years. And that's the kind of construction that we are really dealing with right now, just to give a sense of what is the scale that we are looking at. So what does that mean? So that's how we started to think, what does that mean for the future of India? Are we looking at the entire next generation and the generation after that going to school with masks, going to say cultural activities with masks? And are we dealing with this the same way of how we are going to look at it in the future as well right now? And this sort of gives us a sense of what we are really heading to from now with respect to the entire air pollution as an issue. And then trying to relate that back with the construction industry. We started to look at it from this perspective because everyone has been dealing with air pollution at a very small scale. It would be, say, I have an air purifier, table air purifier, but this is a global phenomenon, and it's been caused by the building and the construction industry, which is responsible for 39% of the energy-related carbon emissions. And that's huge. 39% is huge. So why don't we look at it with that sort of a perspective and lens? Because if you look at Delhi, that's the fabric of Delhi right now. And the smaller pockets that you see, those are trees. Those are trees, basically. So that's the fabric of Delhi, and it's entirely concrete right now. And I'm sure that there will be a lot of other places that we can relate to, which we are building like this, left, right, and center. And looking at that scale, so having gone from, say, air pollution as an issue, coming down to the construction industry, now what can we do? Can we build some alternative methods or some products around this? So it would be interesting to understand what is the life cycle of products that we really have right now, and how do we build anything or manufacture anything. What we do is we first mine the raw materials. Then we go into an industrialized process, which is a heat, beat, and treat. And then we sort of package, and then we ship them from one corner of the world to the other corner of the world, because of there's a consumption led demand, basically. And then we sort of consume them and discard them. And this is exactly the linear economy of products that we are really building at the moment. And this is what I think we need to really change into a circular based economy. Products. So all the products that we build need to sort of evolve around a circular economy based products. And there will be waste within this circle as well. We have to sort of build smaller circles around this circle and try to complete the loop as much as possible. So when we have a waste and we sort of reduce the value of the product if we reuse it, that's called down cycle. What we are trying to do is we are trying to increase the value of the product from the waste that is originally found. And that's upcycling of the product. And we're trying to upcycle the air pollution, which is essentially harmful as a waste, and then trying to create higher grade value materials with that. But then we start to think, if we have to deal with this from the construction point of view, from the architecture point of view, is this a technological challenge? Is this something that can be solved only through technology? Can this be solved with respect to an architectural intervention? Can we really do that? Can we look at it with that perspective and then solve this issue? So then we started to look at, can we build products around upcycling air pollution as such, having an entire context of what impact it has on the environment and the people that are there around us. That's where we started Carboncraft Design, and then we started research over this for almost 3 years around this in Bombay, and started to look at this. And after 3 years of our trial and error, we started a few products, we failed in a few, we came into this style now. And we realized that there are two issues with air pollution. First one is how do you capture it? And the second one is, what do you do with it? And we didn't know this until last year. We were trying to figure out how do we capture it. We were trying to figure out how do we solve this issue. We were trying to figure out where does it really fit in? What is the product market fit? Is there a business around this? There are so many issues that we're trying to deal with. And that's where we came down to at the end of the day, that how do you capture it and what do you do with this? These are two main issues. And we realized that we cannot deal with both at the same time. So we deal with the first part. We've partnered with Airing, and they have a tech that they work with us where they capture, collect, process the carbon emissions, and then they hand it over to us. What we do with this is we take this carbon emissions and then work with what can this material do, and then try to create higher grade value materials with this. We try to say, mix it with various other binders and materials, and then try create some sort of a product around this, which is going to go into a market fit solution. And that's essentially how Carboncraft Design as a company was born. And we started to look at air pollution as an issue where we are focused into certain part of that and then dealing with just that as a major product of what we are developing. And that's when we came into a tile. So I'll just give a brief history of how did we really come down to tile. It wasn't as straightforward and simple as it looks right now that, hey, we looked at this, we partnered with them, and then now we came down to making a tile. We tried earlier a brick. We tried to first a brick. I don't know if you guys can see this. I can't see myself. Can you guys see this? That is the air pollution. And it's been wrapped in two plastics right now, and it's that small. It's a powder essentially.
And how many volumetric of what, so like what was it originally before it became that?
Right. So it depends from where you capture it. Again, it comes from various sources. It can be from chimneys. It can be from source of, say, a diesel generator. It can be a car. So every source is going to give you a different sort of a metric to this. So this is from the chimneys that is there, which has been collected, heaped, and then put together. Basically, we had a huge part of it. And then this is the first thing that when I met Anirudh from Airing, and then that's what he gave me about 3 years ago. And he told me that let's try and make a brick with this and keep that as something that you would want to sort of look at all the time. And when we started with the brick, we realized that we can make it, but then who's going to buy it? Because right now we get bricks in India for somewhere about 4 cents. Wow. That's all. 4 cents a brick. And who's going to buy it? No one's going to buy it because there's no commercial viability for that. So that's when we realized that it doesn't have any design element to it. And it doesn't have any sort of a commercial scalability to it. That's when we moved on from that. And then we moved into a facade, an element that goes on the exterior of a building. In India, we say, jo dikhta hai, wo bikhta hai. Essentially, that means whatever you see from outside is what really sells, because that's exactly how it works. So if it looks really good from outside, it's really something fantastic. So that's That's how we sort of moved into a facade, and then people will pay for it. But then we realized that you cannot scale it. There is no commercial scalability to it. You can make it, people will buy it, but that will be only limited. People who have money will be able to buy it, but not others. Then that's exactly when we moved into a tile, because tile had a certain design value, A, and B, it had a commercial scalability value. So that's how we moved into a tile, and then we started to see how tile could be built. So now we have essentially 4 area of focus. Essentially that is, say, air pollution. Then we have all that we've seen earlier of what air pollution is, its impact. Then impact has, again, a certain environmental impact. It has a social impact, and how we are trying to tackle these issues with that. We were then also trying to understand how we are really going to build this, because now when we're talking about manufacturing, we had to also make sure that the carbon emissions of manufacturing this is low. And that's how we started to find out various means of making this tile, because tile is something that goes in every house. It has a sense of art to it. You can sort of use a certain taste of what you like, and have that sort of a sense of, say, belonging to a space. So when we started to look at that, craft was very it was very dear to us. We thought that, why don't we look at a certain craft when we can get these local communities to build that? Because earlier, which is about 200 years, 100 years ago, we used to use these crafts very, very efficiently. But at that time, I think that's exactly when all the other products with respect to cement and all these other products that came in, and then this craft was left behind only because it could not cater to the volume that it was dealing with. And that's where now it has become a very sort of extinct craft, which we are trying to revive in a certain way and empower the local community with that. So these are 4 areas of focus that we are dealing with right now. And that's when we thought that, why can't we put this together entirely into a tile? So we are saying that we'll come up with a certain design which has a fusion of this. We are using a certain old craft, and then we are fusing this new technology in a certain way and fuse it to form a certain product which is innovative and having a certain environmental impact to it. So then we built more into that, and then we started to learn about this craft. So in craft, there are 2 crafts right now. So the first craft is the stencil making itself. Like, if you have a design, you need to make a certain mold, a certain stencil to it, and that comes from the local craftsmen over there. They cut it, they mold it, they shape it, and then they pour it, essentially, and then you form a tile. And that's how a tile is formed. And these are the molds that has been sort of taken into that, and then how you put them together. The second craft is around really making the tile. So this is a different craftsman. So the earlier craftsmen will only make the mold, and these craftsmen will really make the tile. So these are 2 different craftsmen. Although they live in the same community, they don't know each other's craft. So this has been sort of information, and the skill has been transferred from one generation to the other, and they've learned this by doing. And these craftsmen, they help us to build this tile by having a specific technique of how you sort of pour it, where you pour it, what is the viscosity, and how you sort of remove it at a certain sort of a junction. Looking at impact, there are 2 impacts in this. One is the environmental impact. So environmental impact is, we say that 1 carbon tile is equal to 1 day of clean air for a person. So essentially, it is talking about 30,000 liters of air. I think that's one of the questions that you even asked earlier in a certain way. That's about 30,000 liters of air is what it sort of avoids from being polluted.
Wow.
That's 1 carbon tile, essentially. Then we start to look at the social impact that we are dealing with. So I think we did not really to be honest, we not really go out as a way that we're going to use craft and build it with that. But our major intention was to try figure out how we can reduce the carbon emissions to really make this. And then we try to find various ways of doing it. And then we found this craft around that. And that's how we really looked at that. And then we realized that this becomes a social responsibility now, having looked at a community where there are only a dozen of people, somewhere about 10, and how can we grow this community to somewhere about 50, starting with in this year right now. And then we sort of decentralize this from one small little city, probably a 3-tier city, not even a mega city. It's a small town in India, and then you take it global to sort of various decentralized locations, and you teach this craft to various people, and then you can build it, because the entire technology is just the same. We're using the same hydraulic press. We are using the same sort of a material that's available everywhere, which is air pollution and the other elements around that. But we are trying to fuse this both into a decentralized system, essentially. So that's the sort of impact with the community that we're trying to see how we can build this and help them thrive in a certain way. So in terms of design series, we have 2 series. One is Identile and the other one is Industyle. So Identile essentially means taking inspiration from the identities of the cities. So we have these four cities, and how we can sort of take various patterns, local imagery from there, and then try to derive patterns that define that city in a certain way and fuse it with a natural element. So say Beijing, we all know Beijing as a certain vibe that it has. It has this endless knot. We then looked at the mountains that we see around the city, and we then try to see how we can merge that in the form of a main tile, and then a supporting tile, and then a plain tile. We put them together to form various sort of spaces with that, and how we put that together in the form of a black and white tile, and then everything else is color. Absolutely everything else is color. So that brings us into a challenge that we are facing right now. This color palette is a major challenge for us. We work with only black, white, and 4 grays. We don't have any colors. That's also because air pollution has no sort of a standardized way of collecting. It can be less gray, it can be more gray. It depends on where you burn it, how you burn it, what you burn, and what temperature you burn, and what fuel you use to burn. So there are so many parameters right now. It is not regularized. And that's one of the issues that we are also facing right now, to get a very standardized gray. If I'm telling you this gray, it has to be this gray, because you will want exactly that gray. But if you tell me I want that specific pink, we will not be able to give it to you right now, because I don't know if I will get this gray to get that pink, essentially. So these are challenges that we're also facing right now, and we're trying to see how we can regularize this overall. So we say that the overall batch might remain the same, but if I have to make a new batch for you, that might change a little. It'll have a tolerance of somewhere about 3 to 5% overall. So in the style is taking inspiration from the industries, which are heavy emitting sort of industries, and then trying to derive a certain pattern from there for them. So say paper industry, which also has so much carbon emissions, the first thing that comes to our mind, which is a natural element, is a leaf, and how we can take a leaf and create various patterns from that geometry and derive something, say traditional, something modern, and a mix of both, and has a variation of that as well while you put them together. If you put them into a space, everything else is color, and that's just black and white. That sort of blends into the space overall, and it doesn't speak loudly. In terms of specification, the sizes are, I mean, this is just a technical specification with that. It's available in 8" by 8", 10 by 10, 12 by 12. It can go up to 2 feet by 4 feet, which is 0.6 meters by 1.2 meters. We can make this in any shape. We've done lab tests for this. the wet transfer strength is 3 newtons per mm square, which essentially means that you can put a truckload on it and it will not break. And water absorption, which is about less than 10%. So these are ISO standards that we're dealing with. I want to leave this presentation and you people on this note where Puck Minister Fuller says it, that if you look at air pollution as, or for the matter, any pollution as a resource, we'll feel that we're not harvesting it. And the moment we are able to harvest any resource and reuse it, I think we'll be able to create higher grade value with that. And that's one of the ways of what we are trying to sort of complete our loop in a certain way. And we yet have certain loopholes in our own loop, but we are trying to get there eventually.
Thank you so much. That was fantastic. You know, the one thing that I thought was so unexpected is how you integrated the craftsman into this whole experience. So I love how you're kind of tackling pollution, but also social inequity when it comes to you know, creating a product basically, and who and almost social, like, tell about probably where they're getting their work from before.
Your voice is just cracking, but I can hear you now.
Yeah, so what I was saying was, what were these craftsmen doing before you guys came along? Like, did they have a lot of opportunity for fundamentally transformed their work and how much they earn?
So, how much they earn? How much they earn would be how much they would earn earlier. Would be somewhere about $150.
Wow. Okay.
Yeah, that's about it. Yeah. And we've realized that if we don't do this, probably their skill will sort of die at the end of the day, because they are not teaching this to their children or to their people in the community, because even the community that they had, there was an entire village of people who knew about this, and they have slowly started to move, and they're going into some other unskilled jobs. They're learning how to lay a brick, they're trying to learn how to plaster, and other skills is what they're learning right now, which is what is required for a construction industry, and not this. And the construction industry is the industry which is creating this entire air pollution. So we thought, why don't we use this craft itself and use the skill that they have with the craftsmen to build something around this. There are challenges, I would say, that we are dealing with. How do we sort of keep the demand out for this? That's one of the challenges that we're dealing with. The other challenge is, how do we skill people? Because it's a craft that people have learned over generations.
Yeah.
For us to learn, and we tried it, we couldn't do it. We couldn't learn it ourselves, and it's not easy.
Yeah. And do you feel like because they've been introduced to you guys and they've seen the opportunity, that would probably encourage them to actually pass these skills down?
Yeah. A lot of the people are right now looking at how they can sort of get more people to know about this and how they can exchange knowledge around this. Actually, there are other people who are doing it in various parts of India, and now we're also trying to connect with them so that they can cross-learn between themselves as well.
Yeah.
Of how a certain location and a craftsman in that area are doing it a little bit differently than how they are doing it over here. And it's so nice to see them talk and teach other people with that.
Yeah,
so they are quite positive.
They're building a community around a craft that's not just like central to where they live. It's kind of expanding, which is so nice to see. Yeah.
I'm seeing a lot of challenge around also the idea that how do we sort of keep them together? Because we need a certain demand, uh, because it can't be a one-sided a solution. There has to be a certain demand for a certain supply. If the demand and supply doesn't match, it goes into a trouble. That's exactly what we are facing right now as well, I guess.
Yeah.
We have a lot in a COVID situation. We have a capacity for so much demand, but there's no supply. And at the other end, we don't have supply, but then we have so much demand. So it needs to meet.
Yeah, absolutely. And I think like that kind of nicely brings it on to one of the questions the audience has, which is this concept of production scalable in other countries, or even, scalable where you are, agnostic of the whole, supply demand issue? Because I think supply and demand is determined by creation of a market. But in terms of the actual practical scalability,
So we've been working on the scalability part of it, and we also took this product up because also we can see that there is a way of decentralizing this entire system. So, for example, we are working with a company called as JSW in India, and they are huge as a company, and they are into a lot of various infrastructure projects and other products as well. So what we told them was, how can we sort of look at your own carbon emissions and decentralize our unit and place it near your industry and make it for your own infrastructure needs? And that makes absolute sense, because now they're also coming up with a township project. So for a township project, and we say that, imagine if we can take your own carbon emissions and set up a unit, because our unit is not really big. We just need the right skilled people. That's all. That's because we have the raw material which you are giving us as well.
Yeah.
And we just need the skilled people, and the machine is really small. So it's just a hydraulic press, and you press it and then you sort of keep it. So it's not a very sort of a difficult space consuming sort of infrastructure that you really need. So we are looking at that. I think what we're trying to do right now is move into a certain target that we want to reach, say about 10,000 square meters is what we want to go with. And we sell this in this year. And we find various distributors all around the world who would want to sort of distribute it right now. That's one more issue that I want to talk about, probably, because the moment you transport this, there is carbon emissions in transporting it from one place to the other. And that's the raw material that we're dealing with.
Yeah.
And that's exactly the decentralized system will work. But it's like a chicken and egg situation. What comes first? Does a demand come first or the supply comes first? So we can't like solve the situation. We have to like see if there is a demand over there. We first send out our products, and then we see that if there's a demand, if there's more and more demand, that's when we'll have a decentralized system over there. And that is when I think we'll be able to scale a lot more than being able to scale by just shipping at the moment. Because that's also one more major issue. Not only shipping internationally, we are dealing with that also in India, because India is really huge. If I have to transport from one place to the other, it takes miles and miles of road network that I really need to go through, and that's the major pollution that happens. So it'll be so bad to say that, okay, I transported from point A to point B, but I had more carbon emissions in transporting from point A to point B than what I really sequestered for you.
Yeah, true. And I think so, therefore, the model that's more pertinent to push is to actually localize where the requirement is, right? And so that brings me nicely onto another question from a user saying that, from an attendee who goes, is it possible to take the residual material and give it to other craftsmen around the world to see what they would create from it?
Sorry, your initial part got a bit.
So the question is it possible to take the raw material, so the powder that you showed me, and possibly send it to other craftsmen around the world to see what they produce with it?
Yeah, absolutely. I mean, frankly, I don't need to give it to anyone. It's just there everywhere right now. So I don't need to transport it myself. But yeah, But what one needs to take care of it, I think I could mention this. So when we partnered with a company, the reason why we partnered is safety, majorly. Because when you take it from the air or from these chimneys, there are various scrubs available. There are various other equipments that are available from which you can capture it. But the problem that happens is there is safety. One needs to capture it, then one needs to collect it, and one needs to process it. Because the processing bit is the most important bit here. It will have heavy metals, it will have all the other elements into that. We need to be able to remove that and then be able to use it, basically. Earlier, when we saw, we also got say metals in it. We got like other elements as well that came through that. These are very small, fine metal threads as well that came in, because it flies off and then it comes in with that. So we need to really see and process the raw material. Yeah, it's a bit dangerous as well. So when our craftsmen are using it, you might have seen they have gloves, they have masks, they have like all of those equipments on while they are working with it, because it's not really safe. So that's one thing I would recommend. But yes, you can already do that in your own area as well, and then try to figure out what your craftsmen can come with that. I'm sure that this is going to become the next big thing. In my mind, carbon emission is increasing so much right now. And what we are doing is, if you look at all these chimneys and these factories, they're only dumping it into the water bodies or any landfills. So we should be able to use it.
I completely agree with you. And I think there's so many innovative directions that you can go down with such an interesting product. I also noticed that we can the byproduct is also things like ink. Is that correct?
The amount of?
The byproducts, so when we capture air pollution, like you said, you guys would upcycle it into am I correct in understanding you can also translate that into inks and dyes? Is that correct?
Yeah. So when we spoke to Air Ink, so Air Ink is the company with whom we are collaborating. They already make inks out of this.
Wow.
So yes. And with ink, you can only imagine what all can you do. So I'll give you a fact around this. I think that will help everyone sort of get a sense of what we are trying to do. With inks, this comes in very handy, basically. So everything black that you see around you right now, anything black that you can see, it can be my t-shirt, it can be my headphones, it can be the black behind that I can see. Anything black is made out of carbon black. So carbon black is a pigment. It is made out of carbon black. And how carbon black is produced right now, in most of these carbon blacks are produced by burning the fossil fuels in a controlled environment to get this soot. That's how you get carbon black. That's how it is sort of regularized as a black color, essentially. Right? And what we are collecting is black carbon. Yeah. This is carbon black, and this is black carbon.
Yeah.
So we are right now looking at black carbon and making everything sort of that can go into.
Yeah.
So now imagine the extent of use of this black carbon that can go into our world that we are living in right now. It can be your kajal. We also don't ask the eyeliner that we use. Like we don't even ask about that. Like that has carbon black.
Yeah.
Essentially has carbon black.
Yeah.
But we will always ask this is black carbon, how safe it is, how. But if you compare these two together and you say that this is as safe as this, then it's essentially you're using all of this.
Yeah. No,
so I use it any pigment. Yeah.
Wow, that is also so interesting. So another question from the audience is, are you open to collaborating on different avenues on where you can take these products?
More than happy. I think we want to upcycle more and more carbon emissions. That's our major aim. If that's possible, I think we would love to collaborate. And we personally feel that, say, collaboration is the only way forward right now. If you have to solve real world problems, you have to collaborate, and you have to be open to sort of say building a team which is not just your core. and
Yeah,
around it.
absolutely. I mean, it's one of the central tenets of sustainable development: partnerships, collaboration, community. Speakers when they talk about their mission and what they're trying to do. So we've got about 5 minutes left. I've got two more questions, so you might have to speed through these ones. One is a personal one about you, and the other one is about the product. So I'll do the product one first. So they ask, is there a certain type of PPE that they have to utilize? And an industry standard for the craftsmen to be wearing when they work with this product?
Yeah, I think it is advisable. They have to wear a certain say protection sort of a
Mask.
PPE. Yeah. So when we started with this, we realized that we've already removed the heavy metals and the harmful elements from the carbon emissions. So this becomes then a safety use sort of uh, powder to work with. But yet, for safety, we are yet using the hand gloves. We are yet using the masks that you see in all of our content that we are using as well, and in the factory as well. So I think more and more precautions will move into as we move ahead. So there is a certain gear set that people use, and we are regularizing that as we move ahead. But the craftsmen are not really used to it. The moment they wear a mask, like I can't breathe.
Like I want to take it off.
I
Yeah.
can't breathe, and they have a certain say tactility with the spatula and all that, like the tools that they have. So they have to stop at a certain point where they have to stop, and they don't get that with the gloves.
Yeah.
So
Yeah.
those are different issues that we are dealing with.
Yeah. I mean, it's like with anything that's new, innovative, or, pioneering, there's so much to learn whilst you do it as well. So I
Yeah.
completely appreciate the challenges. So the final question is, hey Tejas, this is such an interesting concept. What was the spark moment when you decided you were going to go down this rabbit hole? It's like
Sorry,
Alice in Wonderland. He said,
oh,
what was the spark moment when you decided I'm going to do something about this? Like, what were you thinking, or what was it that ignited I'm going to go and solve this problem?
so I think the interest was always around curiosity. I would say
Mhm.
I was only curious about learning about new materials, and that's been the major focus on uh, how you can learn about new materials and build uh, say solutions for real world problems.
Hmm.
And while I was doing that, I saw this raw material, which is what Anirudh was doing from air ink, and they were making inks out of this. And I was doing a project for a visiting school, an installation that we were doing with a Gustavino wall. So like, why can't we make bricks out of this? And he liked the idea, and then we started with that, and that's where we've come from that journey.
I love that. I love that. Because I think sometimes we really underestimate how those little moments where you go, let's start this, so I think that's really encouraging for those who are watching. And so just to let you know, we have investors watching, we have founders, we have subject matter experts, but most importantly, we have lots of students. So I'm sure you're going to have inspired so many people with it. Details into the hub forum. So if anyone wants to chat to you, they can. Yeah. Okay. Awesome. So one last thing I wanted to say. Thank you so much. Sorry about all of the tech problems we've been having today, but we've been having them across the board. I would be more than happy to advocate what you guys do from me, whether it's through connecting you with the right people, anyone within our network, and also for all of those who are watching who did have a community in London that is truly behind the work that you're doing.
Thank you, Nimisha. Thanks a
You're
lot for everything. I'm grateful that I have this opportunity to be able to share it with everyone.
Well, thank you so much. And it's been a pleasure talking to you. It's been a pleasure having you speak about such an important topic. And we really look forward to doing this again with you.
Thank you. Thank you.
Bye.